So to continue the biostats, I want to talk about ARR, the AR, NNT, NNH. What the hell are these guys? Okay, so ARR is attributable risk reduction, and then the AR is the attributable risk. So basically they're the same exact thing. The only difference is that the AR, this guy, he's the probability that the disease is going to go down to treatment. So disease down for treatment. So if you do treatment, the disease should go down, right? And then the ARR is that the probability of getting the disease, so probability of disease, is going to go up if you were exposed or not. But when it comes to calculations, it's basically the same exact thing. Now, NNT is number needed to treat, so the amount of people you're going to need to treat to change the number, and then NNH is going to be the number needed to harm. So the numbers needed to harm someone. So this is just going to be these equations are going to be basically the same too. So these guys are the same and these guys are the same. But how the hell does this all correlate? So let's just do it. Let me erase this real quick. So now, what is AR? Well, attributable risk, or ARR, attributable risk rate, are kind of similar. So we're going to go ARR. So this formula is going to be the event that you need to control, right? So the control group minus the treatment group. So the people who are getting treated and the people who are the control group minus the treatment group. That's going to be this equation, right? ARR/AR, same thing. Okay, and now number needed to treat or number needed to harm is going to be basically similar. NNT over number needed to harm. All this is going to equal is 1 over ARR. Okay, so this is all the NNT or NNHs is 1 over this number. So ARR, the way to get that is to use this formula. So let's do it in a question because it usually makes more sense when you do it that way. The consumption of red meat is examined in a study of the incidence of colorectal cancer. 1,000 subjects were enrolled in the study, and the results are shown in the table below. All right, same exact table I brought from before when I talked about specificity, sensitivity, PPV, MPV, right? Well, these tables really do a lot for us. They basically get us through every question. So here we go. Which of the following is the attributable risk of developing colorectal cancer because of consuming red meat during the study period? Okay, what in the world is this one asking us? All right, so we know it's asking us about attributable risk, and we know we have a formula for that, right? So what's the formula for attributable risk? Well, this is how we're going to do it. We're going to write Okay, so to break it down, I usually like rewriting the whole entire table. I don't know why, just it helps me. But let's do it. The consumption of red meat is examined in a study on the incidence of colorectal cancer. 1,000 subjects were enrolled in the study, and the results are shown in the table. Boom. Which of the following is the attributable risk of developing colorectal cancer because of consuming red meat during the study period? Okay, I'm rewriting it because that's what I do. So if we rewrite it, I should do that in black. Makes it look better. Okay, we rewrite it, and what are we going to do? Okay, well, so we know the top is reality, always. And we know the left is usually test or something, right? But what is it asking for? Well, it's attributable risk, so, okay. This might be exposure to something. So the exposure of something. And we know we have plus minus, right? So now, reality, they're developing cancer. The test, well, if they ate meat or not, so I'm going to write meat consumption. Meat consumption. Okay, so we have 100 in this column, or in that box, sorry, 400 in this box, 25 in this box, and 475. Okay, that's what the table gave us. So now, remember we read the questions from left to right. So which of the following is the risk of developing colorectal cancer because of consuming red meat? Okay, so because of red meat. Well, AR is going to be our exposure group minus our non-exposure group. Okay, because they said if you develop cancer, right, it's either you're exposed or you aren't exposed. All right, so all you got to do for the formula now is go like this. AR, attributable risk, is going to be 100, right? So attributable risk, we're basically doing PPV again. So we're going to go 100 over 100 plus 400, right? And then we're going to subtract this value from what? Well, we got to do the same thing. We got to go this way. Exposure, we got to do 25 over 25 plus 475. Okay, so so it's going to be our exposed group up top versus our non-exposed group on the bottom. Okay, and all you got to do is subtract them. AR is going to equal 100 over 500 minus 25 over 500, which is going to equal 75 over 500. Need a calculator. My apologies. Let's see what that is. 75 divided by 500. Okay, so this is going to give us 0.15. So our attributable risk is going to equal 0.15. Not too bad. Now, what if they asked us for the harm, right? Or the NNT, the number to treat. Number needed to treat. We could do that one, or we could do number needed to harm. Let's just do number needed to harm, right? Okay. So number needed to harm is going to be NNH, and that's going to be 1. NNH is going to equal 1 over AR, or what? 1 over ARR, same thing. So we're going to take NNH, number needed to harm, is going to equal 1 over our AR, which is 0.15. Okay, so calculator time again. Let's see, where is he? 1 divided by 0.15 is going to equal 1 over 0.15. It's going to equal 6.67. Okay, so our number needed to harm is going to be 6.67. That's not too bad. So we know how to do this guy. What is number needed to harm? It's the number of patients who need to be exposed to the risk factor for one patient to be harmed. So what does that mean? So you need 6.67 people, right, to be exposed or to eat meat in order for one of them to be harmed. But is it 6.67? Technically, but it's really 7. You can't have 6.67 people. You can't have 6.5 of a person. So you got to round up to 7 whenever you're talking about numbers needed to treat or numbers needing to harm people. That's really not too bad. Okay, so now we're going to talk about another question. This one's a little more detailed. It's going to ask a couple more things, but shouldn't be too bad because we know how to do the table and everything else, so we should be fine. Researchers designed the cohort study. Okay, so cohort, what is this? Cohort is what? Well, relative risk. I don't know if this is important, but that's how I remember. Cohort relative risk. It might be of importance. To elevate several risk factors for stroke, okay? They recruited participants according to their hypertension status, exposure, and without a medical history of stroke and followed them into the future. Well, the future, we know cohort is in the future, right? Okay. Once the study finished, researchers assessed the presence or absence of a medical history. So if they had a medical history or if they didn't have a medical history of stroke in all the patients, they obtained the following data. So we're going to do how I like to do it. You could skip the video if you don't like it, but recreate your table so you understand it in your head, in your own mind. Sometimes you could just read the table, it gets confusing. So reality up top, what was the reality? Okay, a stroke. So we know we have a stroke. And the test, well, what's the test? Well, hypertension, they say, but present or absent. Well, they finished, the researchers assessed the presence or absence of a medical history. Oh, so the test is if they were tested or not, a medical history or not. So if they were tested or if they weren't tested. And then up here, we know it's stroke or non-stroke. We know that. Okay, so now, if they got tested or if they didn't get tested. If they had a stroke or if they didn't have a stroke. Well, let's just plug in the values they gave us. Let's not get too confused. The values on the side, these things, honestly, I crossed them out. Like, they're meant to, like, confuse me, to be honest with you. I don't like them. I don't like them at all. It's just the sum of everything added together. Like, I don't want the sum. I could do it on my own. Because I might plug in one of these values by accident. Like, no, get out of here. All right, so what is it asking us, though? Is it asking about relative risk or case odds ratio? No. So everything I wrote up here, we could abandon him, but it was worth a try. But what is it asking? What is the attributable risk percentage attributable to hypertension? Okay, so that's really worded interesting, but what is it really asking? It's asking for the AR, right? And they're asking for AR percentage. Well, don't get mixed up when it says AR percentage. It's the same thing as AR. Just to get the percent, you just have to multiply it by 100. That's why I do everything in hundreds. All right, so what is AR again? Oh, boy. Attributable risk was, you could do control minus treatment. No, that was ARR, right? So that's not that. But it's the same exact thing, right? Except what? Exposure minus not exposed, right? So you were exposed or you weren't exposed. But in this case scenario, what is it testing? If you were tested for hypertension or if you weren't tested for hypertension, were not tested for hypertension. So test or no test, right? Really not too bad. Like, it's all the same. They're all the same thing. So if you ever get confused, it doesn't matter. Just do. If all you remember is exposed versus unexposed, write that. If all you remember is control versus treatment, write that. Like, it'll all add up to the same value eventually. Okay, so we know that's what it is. Let's erase him because the clutter bothers me. Okay, so AR, we do tested minus no test. Okay, so how are we going to break this down? We're going to start on the top and we're going to go this way. So we're going to go 200 over 200 plus 15 minus what? Well, same thing. Now we just have to go no test. If they weren't tested, 150 over 150 plus 200. And what does this mean, like the 200 over 200 plus 15? Well, they got tested, but it's whether they had it or they didn't have it. They didn't get tested, but did they have a stroke or did they not have a stroke? That's all it's testing for. All right, but that's besides the point. If you really want to learn it, it doesn't really help you with the equations too much if you know how to set up this chart. But let's do it. So you do 200 over 215 minus 150 over 350. And I cannot do this math in my head, so we're just going to do 200 over 215. I'm not doing it all at once because sometimes the numbers get all juggled up in the calculator, and I don't want to make an error. So 0.93, and then you do 150 over what? 350? Okay. You get 0.428. Oh, that's really bad. I don't know. My bad. You get 0.428. So 0.43 basically, right? We could round here. It's not too important. So if you subtract them, AR equals 0.93 minus 0.43. Well, that's going to equal 0.5. So we know that's what the AR is. But what do they ask us? Well, they asked us for the AR attributable risk percentage. So we're going to do AR percent equals 0.5 times, all you got to do is times 100, because we're working in hundreds here. That's how I like to do it. We're going to get 50%. So our attributable risk percentage is going to equal 50%. Boom. Not bad. Now, next question. Which is the NNH number? Okay. Well, I'm going to erase this, guys, because we already know how to calculate this. NNH. What the hell is NNH? Well, just don't get nervous. Remember, NNH, number needed to harm. Number needed to harm is the same as NNT, number needed to treat. So NNH or NNT, same. Okay, so if you remember either of them, you know all it is. So all these guys are equal to is 1 over AR or ARR. Same thing, right? However, when you're putting it in, please do not put in 1 over 50%. It is not going to come out right. The answer is going to be I don't even know. I don't know what that's going to even equal. But that's not going to be right. You have to remember AR, not AR percentage, goes on the bottom. So what was our AR? Our AR was 0.5. So we're going to do 1 over 0.5. And that's going to equal 2. So our number needed to harm is going to be 2. Okay, so that crazy question is really not that bad. Now, this is where I get frustrated with these questions. Here we go. What is the population attributable risk? Okay. Prevalence hypertension in all individuals is 38%. They tell us that, right? That's thankful, but honestly, usually they're not going to give it to you. So what the hell is population attributable risk? Well, the standard definition of it is going to be prevalence of an exposure group over the entire population with people with hypertension or non-hypertension, right? They're going to give all this jargon, all this gibberish to you guys. Don't deal with it. Just remember this. PAR, right? So population, it's the equation for this right here. So the prevalence of hypertension in all individuals is going to be PAR. Okay, and what does PAR equal? So it's going to equal that. This is what they're going to tell you. It's going to say that ARI times the prevalence of exposure in population, right? That's what they say. What do these numbers mean? Well, they gave us the prevalence of exposure in the population is 38%, but let's just do a quick run through. How can we get this on our own if they didn't give it to us? Not too bad. What is prevalence? So prevalence equals the number of people who got sick who got sick, right? Over the total population. So the people who are sick over the total population. So who are the people who are sick? 200 over 15, right? The positive, the only way you could be treated or not, or determine if you were sick or not, is if you got tested. So this is how you're going to determine the prevalence of the exposed population. So this is the exposure, prevalence of the exposure population. So they were only exposed if they got tested. Okay, so it's going to be 215. And what's the total population? Well, the total population, you just have to add all these 4 things up. And we're going to do 200 plus 200 plus 150 plus 15. And it's going to equal 565. But I'm not going to put that, I'm not doing this math. I'm going to put it in the calculator. So we're going to do 215 over 565. And it's going to equal 0.38. But I thought I said the prevalence of hypertension is 38%. Yeah, that's the number they gave us. But are we going to use 38% in the formula? No, we're going to always use 0.38. So if you can't figure out or distinguish why, just go back to your basics, to the top over the entire thing. So the top over here over the entire thing, and you're going to get this number. Okay, so now what is ARI? Well, ARI is just another way to say the AR, the attributable risk. That's all it is. It's another way to say that. I don't know why they do this. So 200, right, over, 215 minus 150 over 350. This is how we got the AR is going to equal 0.5, remember? How did we get this one? We did 200 over 200 plus 15 minus 150 over 150 plus 200, right? From this chart over here. Same exact thing. I don't know why they call it this. I don't know. I don't understand. Just remember, all this is, the ARI is going to be your attributable risk. Okay? So now, let me change the color. So we have 0.38, right? We have our first one. We have our second one, 0.5. What is the calculation? PAR, all it's going to be is attributable risk times prevalence. So remember, attributable risk, I don't even know how to spell. Attributable risk times the prevalence. Okay, so if you know that's your attributable risk, this is your prevalence, it should be fine. So 0.5 times 0.38. Don't know what this is, but I'll do it. 0.5 times 0.38 is going to be 0.19. Now, when they ask for the PAR percentage, so they said the population attributable risk, that means the percentage of it. So it's PAR percentage. That's what I should have wrote. How do we get percentage? All we do is multiply it by 100. So we're going to get 19%. That's how we're going to get, or that's how we are going to get the PAR. So all this stuff is really not too bad if you break it down and understand it in layman's terms. I don't know why they have to go so crazy and try to confuse people, but yeah, I hope it